Hello, my name is Dustin Nance, and this is General Chemistry 2 Iodine Clock Lab. So, the first thing is to create our solutions, A and B. Solution A is a composition of vitamin C, iodine, and distilled water for this clock. I mirrored the video presented as closely as I could with 2,000 milligrams of vitamin C crushed up tablets, approximately 25 mLs of propionic iodide. It was the only thing that I had available, so I had to use it instead of the tinctures that he used. And then approximately 60 mLs of distilled water. This was just for the initial mixing of the solution, and then extra distilled water was added. That way there would be equal amounts of solution A and B. Solution B was a combination of hydrogen peroxide, cornstarch, and distilled water. It was 150 mLs of hydrogen peroxide, 0.4 grams of cornstarch, and 350 mLs of distilled water. And the distilled water for both of these solutions was heated to encourage the dissolving of the products as more thorough dissolving of the vitamin and cornstarch would result in a smoother, quicker reaction. So here are some videos of the solutions being created in no specific order. This is the addition of the distilled water to the vitamin C, stirring it, trying to get it to mix. It is a little bit cloudy, so you'll see in one of these steps I mirrored what he did and used a filtration system to try and improve clarity. I'll just skip through this a little bit as it wasn't mixing the best at this time, but I did eventually get it to mix well. Here is the addition of hydrogen peroxide to solution B. This is a quick clip of my filtration system. You can see a filter in the back as well in the front for each respective solution. And here is a clip of me adding the propionic iodide. You can see there's adequate vitamin C as adding the iodine and mixing and agitating it. It did return to colorless if there was not sufficient vitamin C within that solution. Then the iodine would remain visible. It would keep that discoloration. And then now we have a quick clip of the reaction itself. So I add the two solutions together. Again, they are warmed in efforts to encourage the reaction. I mix it. My reaction took about a minute and a half, so I'll skip through slightly. It was quite delayed at first, but you can see at about the 1 minute 10-second mark, actually according to my slider it looks about 1:15, the reaction starts. It moves from a yellow to a darkish orange to brown and blackish. Now, I know that this should have been a more blackish or dark blue, but I'll address what may have been wrong with my lab at the end and discuss it a little bit in detail. But first, we need to discuss what actually happened within this iodine clock reaction. The first thing is that obviously two colorless solutions are competing in different reactions. First, iodine is produced by the reaction from the hydrogen peroxide, and this forms free iodine ions, but these iodine ions are then consumed by the vitamin C. This leads to the delay in the color change, as the ions produced are constantly being consumed by the vitamin, but eventually through the excess of hydrogen peroxide, more iodine ions are created than what there is vitamin C. So once the vitamin C has all been consumed and the initial reaction has subsided, those free ions then react with whatever starch you've used. I used cornstarch, but there's several other starches that could be used, and that can affect color change as well. But those starches react with the iodine to form I2, which is then how you get your color, which is supposed to be that dark blue black. So what were some of the possible issues with my experiment? I have some theories for that. Quite a few of my chemicals that I used were rather old, as in several years old. I'm not sure if this perhaps affected concentration, if perhaps they've gotten weaker. It's just affected their overall quality, as the proton iodide was very old. It was several years old. Cornstarch was an inferior product that was older as well, and I'm unsure of the age of the peroxide. So I think the age of the different components of the solutions had an effect on my experiment, but I do think it produced an adequate result, as we did see the desired sort of reaction where it's the reactions competing, there is a delay, and then there is that swift color change showing that we have progressed from the end of reaction 1 into the end of reaction 2, as both of them have finished competing and produced the final solution. I hope these explanations have been adequate, and I hope that my issues with the experiment have not affected my findings too much, and that I was able to think reasonably and use my complex thinking to still reach the desired thought process in the end. Thank you.